Okay, guys, so let's solve together this problem here. In particular, I want you to be focused on the meaning of this graph, right? So from here, we can say that we are working with impulse first of all. An impulse, you know, is given by force times delta t. Now, I like to write delta t because it's not really an instant, it's your time interval. Being this a time interval, you have to be careful about when you're using the regular math and when you're using calculus instead. So, first of all, I want you to focus on the fact this is your zero mark. Okay, so everything above is positive, obviously, everything below is negative. Now, since we're working with forces times time, we are doing this value here, which is your force, the value of your force, multiplied by time, which is this value here. Now, since you're doing height times the base, you're solving for the area of this little rectangle there. So as you're doing this, right, first of all, when they ask how do you find impulses, well, if this is the value for impulse, this is the equation for impulse, how you calculate your impulse? Well, you solve for area, right, under your curve. Now, if this is the area, though, you can do base times height, so you can use the formula straight up when you're dealing with stuff that are constant. Remember, every single time we work with those equations that are posted on the wall, those are equations that are valid for stuff that are constant. Whenever your acceleration is constant, your velocities are constant. In particular, accelerations are constant. Now, in this case, though, right, since we have a straight line for force, this means your acceleration doesn't change. Well, how do you know that? Well, because you know that force is equal to ma. Since m is just a value, is just a number, if the force is constant, when you divide by mass, you have a constant acceleration as well. So only in this little case here, you have a value of acceleration that is constant. So only in this value here, you can apply your equation for impulse straightforward. But you do understand that we are dealing with areas. So for the second part of your worksheet, when they say which 30 seconds time interval contains a net negative impulse. But if impulse is the area, where do you have negative areas? So you got to figure out that this is below the zero mark. So this is your areas, the areas that are negative, right? But they say which interval of 30 seconds are we considering? Well, so the 30 seconds marks are here, right, and here. So for B, I would say is between 90 and 120, and between 120 and 150 seconds. So those are the two marks. So when we have intervals of areas, obviously they want to, this applies also, but they are not giving us the choice of parts of 30 seconds. Then for the part C, they say, so what is the impulse between 30 and 60? So we got to calculate this value here. So your impulse between 30 and 60 is going to be the amount of force that you have there, right, times your delta interval, delta time. Now, which one is this value here for force? Well, if you check, you have 5 little squares for 20, for a value, for a max value of 20. So to go from 0 to 20, they are using 5 squares. So how much is every one of those 5 squares? Well, it has to be 4 newtons, right? So the 4 times 5 is 20. So if every single one of those is 4 newtons, 3 of those are 12 newtons. So now you have a value of force which is 12 times your delta T is going to go between 60 and 30. So T final minus T initial is 30, right? So that will be your value for for the impulse between 30 and 60 seconds. So this is your value. and the units are Newton because it's a force times a second. So that would be your value for the answer C. Then for D, they ask which one is the impulse between 90 and 120. So for this portion here, which is negative. So for D, your impulse between 90 and 120 is going to be force times height, force times time. But remember, this is not a constant value of your force. The acceleration is going from 0 to a negative value, right? Therefore, you cannot just say that this is force times time. You understand this is an area that we need according to the definition that we have given, but the area for this particular triangle here has to be obviously the area of the triangle. So it's one half times the value of f, which is minus 20, times the time interval, which is 120 minus 90, which is still 30 seconds. So now this is negative 300 Newton second, which is the value, which is the answer for your part D. Then for part E, they have what is the, I lost it again, part E. What is the impulse between 150 and 180? So here, since we're dealing with those areas, right, the area here between 150 and basically 2 squares and a half, and the other 2 squares and a half are between this number and 180. So those two areas are basically the same, right? Because this is 20, the height, and 2.5 squares, and this is 20, the height, 2.5 squares. So negative area and positive area. So we can just say that the impulse between 150 and 180 is going to be 0 Newton second. Then for F, at that point they say, using the information from text above combined with the graph, calculate the final velocity at 60 seconds. So what's going on there is that you are dealing again, right, with this portion of your graph right here. So you're dealing with the impulse between 30 and 60 seconds, for which we already know the value because we said this is 360 Newton seconds. But now, guys, we also have the knowledge that impulse is the same as changing momentum, which is the same as the mass times v final minus v initial. Now, reading the problem, they are saying that the initial velocity in the hill there, I mean, if you read the text, here they say you have coordinate hubs, which is 45 kilograms. I assume this is combined. I mean, we can just agree on it, or you can to me, this means that the combination of those two is 45. They say the irregular shaped, blah, 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 below a force. So they say the initial velocity when they hit the part of the hill depicted on the graph is 11. So initial velocity seems to be 11 meters per second. So from here, we know that the mass is 45. Final velocity is the one that they are asking for, minus the initial meters per second, which is the one that they are starting with. So at this point, we can just say that we have a 360 divided by 45 plus 11. This is going to be your final velocity, which is 19 meters per second. So next question is G, and they want us to calculate final velocity at the 120 mark. So for this one, I would say we need to think a little bit more carefully, because 120 mark is over here, right? We have just calculated the velocity at the 60 mark. So we need to, since those two curves have different slopes, we need to calculate velocity here. Once we have velocity at this point, so once we have the velocity at the 90 mark, we can consider this one as the initial velocity for the new interval between 90 and 120, and then we can calculate the velocity of 120 right there. So how do we calculate the velocity of 90? Well, we will use the velocity we just calculated, which is the v60, which is the 19 seconds, as initial velocity. So we can calculate initial velocity. We can consider initial velocity and final velocity for the interval 60-90. So for part, we said this is g. Okay, I will say so momentum between 60 and 90 is going to be, so we got to calculate this one between 60 and 90. They didn't have us calculate that one yet, so let's calculate that one. And we have a 12 as a height, and we have a 30 as a base, and it's still a triangle between 60 and 90, we said. So the area is going to be 1/2, 12, and 30. So that would be the area of it, right? And then, so this is the impulse, which is going to be the same as Vm, which is the 45. We know that number. And then this is the V at 90 minus the V at 60. So this one was the V at 60. Right, because it was between 30 and 60. So minus the V at 60. So at this point, we can just solve for this. So we know that this is 6, right? 2 and 12, so this is 6 times 3. So 180 is the number divided by 45, because the mass is 45, plus the V at 60, which is 19, is going to be the V at 90. Okay, so, and this number is going to be 180 divided 45 plus 19 is 23 meters per second. So now we have the velocity initial of the interval 90, 120. So if now we consider this, we just found equal to 23. We can solve again, knowing this impulse over here, right? We can consider this one as final velocity and finally answer to the question that they were asking. So J between 90 and 120 is going to be the 1/2 minus 20 is the thingy, and then 30, right, equal to the mass times the V final, which is the one that we want, minus the V at 90, which is the 93. So now this is going to be minus 300 equal to over 45 plus then 23 equal to, this is the V of 120. So 300 divided by 45 negative plus 23. So this is going to be 16.3 meters per second. And for solving then the part F, they ask us to find the final velocity at the end of the ride. So as of now, we are at the point 120, which is up here. So we still need to calculate, to follow the same procedure that we've been doing, we still need to calculate final velocity of 150, because we have the initial velocity for this interval between 120 and 150. So this number we have just calculated, which is the 16.3. We need to calculate this value here. And at that point, we are basically done. Because here we have no impulse, because we have calculated already the fact that the impulse here is 0, because you have this area minus this area, which is equal and opposite. So velocity here is going to be easily calculated, first of all, because we do the impulse between 120 and 150, which is the negative 20 times 30, which is the rectangle, minus 600 is the number, and then equal to change in momentum. So by doing the calculation that we have been doing already, so this is 3, which is your meters per second velocity at the mark 150. Then momentum change, then the impulse is 0 between 150 and 180 seconds, So by being the impulse 0, this means that our change in momentum is also 0. So this means the velocity is constant, which means that at the end of the ride, velocity is still 3 meters per second.